So this is UI UX considerations when there is no keyboard or mouse. This is basically my lessons learned on programming for a touchscreen. And I have lots of demos for this. So I think in order to get through the demos and the slides, I might do a chunk of slides and then go to a chunk of demos instead of trying to go back and forth the whole time. So we'll see how that works. So if you don't know me, you can call me Q. My full name is Quentin Alldredge, but feel free to have anyone call me Q. I got that name for both the Star Trek and James Bond references. Star Trek first for my brothers, and then the James Bond reference from my first job out of school because I made the technicians' jobs easier. And so they named me Q because I made all the techno gadgets that made their job easier. So now I work for Hill Air Force Base. And it's kind of interesting, I wear two hats when I come to events like this because Hill Air Force Base is officially paying my way to be here. But in order to not look like the Air Force is endorsing LabVIEW, which they can't do, and also not having to go through all the trouble of getting approvals to share presentations, I do all of my presentations on my own time after work, with my own code that I program, not on the Air Force's time. And so Q Software Innovations is my own consulting company that I do all that through. And I do some work on the side for other companies as well when there's no conflict of interest with the Air Force. So there's a little about me. Here's how to get a hold of me. That's my avatar, is the LabVIEW Zealot. So if you see that on any of the forums, that's me. And also it's pretty easy because I go by Q, so all of my aliases are the Q. So, or just Q, like on the LabVIEW wiki. Most websites don't let you have just a single letter, so, but the wiki let me, so. I have my hand in lots of different things, as you probably saw. I'm a director of GCentral, which you'll hear about tomorrow from Chris Gelino. And I'm also one of the admins on the LabVIEW wiki, which is why I presented about that. And yeah, so I'm a CLA, I'm a LabVIEW champion. My coworkers tease that the only reason why they made me a LabVIEW champion is because I'm willing to work for free. Because of all of the extra time I put in on my own to make these presentations and toolkits and such. Okay, overview. I'm going to talk about the requirements, the type of touch screens, and then some definitions, and then go into the UI considerations I had for that project and the UX considerations I had for that project. So here's the requirements. Again, these pictures were Googled and freely available, so I didn't use anything from the Air Force, even though I am referencing my Air Force work. All this other stuff is Googleable, and so it's public knowledge. But basically, we were developing for that box right there with the touchscreen tablet on it. And it's called the PAT-70, and it's made to interface with the A-10 aircraft to do maintenance and to load flight software. Now, if you don't know anything about working for the government, they have MIL standards for everything. And there is a MIL standard for human engineering, and this is a pretty long document that tells about not just software, but hardware type interfaces like switches and buttons and stuff for flight controls or whatever. But one of the places in that document, it specifically talks about touchscreen interfaces. And one of the things it talks about is an alphanumeric keyboard. The size of the buttons have to be physically on the screen, a ½ inch by ½ inch, with a ¼ inch spacing between them. And other UI components have to be a minimum of 0.65 inches by 0.65 inches. And so you have to do the math with your screen resolution and come out to how many pixels that is. Another requirement we had was they had to be able to use this on a flight line in Alaska or on a flight line in Saudi Arabia, who knows. And so they had to be able to wear gloves. And so that defined what kind of touchscreen hardware we could use, which we'll talk about next. So type of touchscreens. This is the type of touchscreen most of us are familiar with. This is all your iPads, iPhones. These are modern touchscreens. They don't use a lot of force because they use the electrical capacitance of your finger. And basically they can sense where your finger's at by the electrical components. Cons is you can't use gloves. with this, obviously, unless you have special ones that are conductive, which weren't available when you were working at, -32 in Alaska. So obviously we couldn't use this style of touchscreen. So we had to go to a resistive touchscreen. And this is what you're used to on your old, like, Palm Pilots and such.
Is it true the other ones can be multi-touch and this cannot?
I don't know 100%. I think it's true that resistive touchscreens can't do multi-touch because the nature of them is they're two sets of film, and they make a connection, and know where you're pressing by force of those. You make a connection with those two layers of film.
Okay, thanks.
So I assume that's probably the case. Now, has someone made a resistive multi-touch? I don't know. Maybe that exists.
I think there was one out there somewhere, but
I don't know how well it would work.
yeah.
But
Oh, that's what happened.
now the website that I went to learn about this stuff said that these were accurate, and I would beg to differ. Resistive touchscreens are definitely less accurate than capacitive touchscreens. Now, towards the center of the screen, it's pretty good. Towards the edges of the screen, it gets really more difficult. So anyway, our project had to use a resistive touchscreen. We had to comply to those standards. So a little bit of definitions. Okay, you hear UI, UX all the time. Sometimes they're used interchangeably. The UI is really the appearance of what is the interface. The UX is how someone actually feels about the interface, and how easy is the interface to use. And so that's really the difference between the two definitions. So first off, I'm going to talk about the UI aspect of this. So you can think of this as the UI is what makes the software accessible. The UX is what makes the software easy or difficult to use. So UI considerations. So just first off, thinking through the controls. Okay, well, if you think through all of the different controls that you're going to have in an application, you can have checkboxes, radio buttons, lists, menus. We're going to talk about the on-screen keyboard quite a bit. All of those things most of them, the default ones, are too small for what our requirements were. So I'm going to talk about that. The first one is buttons, checkboxes, and so on. So if you take that screen resolution, we had a 1024 by 768 screen resolution. What that comes out to on the 10.8-inch tablet computer that we had for the PATH 70 is about 119 pixels per inch, which ended up being that our buttons need to be a minimum of 60 pixels by 60 pixels with about 30 pixels in between. So this is kind of the layout we were dealing with. We had to program a whole set of controls. We made them as type defs or strictly type defs, depending on what we needed them for. And we made a library of them that we could drag and drop as we were programming all the rest of the modules. So that was one of the things we had to come up with first, was this library of controls that we would then use in the rest of the project. Then list boxes. So if a list box was just going to display information, it could have small text. It wasn't a big deal. The user could still read it on the screen. But if it was going to be used for selection, we had to do something more with it. One of the things was we had to standardize on a font and make the font big enough so it made the row tall enough to be able to click on. So we ended up, if it was selectable, we used 36-point font. We just standardized on Arial because it was a nice, clean, sans serif font, easy to read. And we also decided to standardize just on the system controls. So most of these will have a standard Windows system control look to it. Yeah, one of the things that we ended up doing toward the end is actually we set up scripts, or you could set up VI Analyzer tests to check that your standards are being met, like the the font sizes are set correctly and things. Or you could use VI scripting to actually force all of your list boxes to be set up correctly. And that's something that we had to consider. So like I said, I have demos for these, but I'm going to go through a set of these and then we're going to go through the demos. So, okay, other considerations, this is where the scroll bars come in. For list boxes, trees, and tables, so that's both the list box and the multi-column list box, you can go in and make the scroll bar bigger. And that's really not that hard. Pre-Windows 10, you could go to the control panel, appearance and personalization, change Windows glass colors, advanced appearance settings, and then change the size of the scroll bar. Now, we were writing for pre-Windows 10 operating system, but we weren't the only one living on the system. Someone else was writing software for the same platform. So we weren't allowed to change the environment variable to make the scroll bar bigger, so we had to go manually make these scroll bars bigger. So, here it is. This is the flag. There's a problem with LabVIEW though. If you go make those scroll bars bigger, which I'm going to show you how to do here in just a minute, if you save that VI and close LabVIEW and reopen it, LabVIEW in all of its wisdom decided to resize the scroll bar for you back to the environment variable. And this was complained about years and years and years ago, and they put in this flag into the INI file that basically turns the auto resize off so that you can keep the scroll bar size the way that you want. And this becomes a pain because as this program got bigger, it got up to 50 modules in size. And if someone in my team didn't have this set, and they opened it up and resaved it, then all of our modules now had the small scroll bars.
So how do you handle if it's an executable?
In an executable, it didn't matter. You don't have to have this in the executables INI. After it's built, it doesn't rerun. This is only in dev time. But what that meant is if in dev time it did get saved back to the small scroll bars, we had to go through and replace every multi-column list box, every tree control, every table, back to the one that has the large scroll bar. And we quickly found out that if we scripted that, it was a lot easier, but it still was a pain to script it and get it right and have it put the multi-column list box back in the right place, reset up the fonts, reset up everything. But yeah, we ended up going through that pain because it was such a big deal. Okay. Strings though, on the other hand, don't let you modify the scroll bar width. So we had to do something different. So if you have heard of my Q Control Toolkit, this is where the Q Control Toolkit's life was started. Was the idea came about from this. I went home, programmed the Q Control Toolkit, got it working, said this is really awesome, it's working great, took it back to the base and said this is what we're using instead of all the X controls that we were using. And there's a whole history behind why we got rid of the X controls, and it's based on PPLs, and I can tell you that story offline, but yeah. So actually, this is probably a good point to go to the demo and show you some of these things real quick. So, I have the demo VI here, and I have, this one's really simple. All it is those checkboxes and radio buttons. I just wanted you to be able to see them in action. Otherwise, that's the checkbox, and that's the radio buttons.
Can't resize that.
You know, so, and those aren't resizable. Now, these are overwritable. You can copy new buttons in, which is what Jim's presentation was showing you with the radio buttons and the buttons. You can put any kind of button in there you want, and the radio button cluster will still work the same. For list boxes, so there's the large scroll bar for the list box. Let's show you how to actually do it. Let's come in here, let's put in, I don't know, let's just put in a regular tree control. Put in that, so I'm in a control. This is actually a .ctl control file. You come in here and you say, I want to change to the customize mode. And then after you do that, you can actually select parts like this thing. And you can can select these and make them bigger. Actually, I should probably, this is the viewable area of the table, and this is the scroll bar. I should have made this control bigger to start with, but that's okay. And then the corner little box. And then after you do that, you turn it back, and now it's all set. Now it's the large scroll bar.
You do that with an array.
I don't know if you can do it with an array.
That's what I needed it for.
Yeah,
The array, 'cause I had a picture control, a vision picture control, and the viewable area and the stuff around the array, it was so many unselectable, unchangeable stuff.
Yeah, I think in an array, I would just go to the Q control scroll bar.
Just the external scroll bar. There is
Yeah.
there is a control bar.
Well, there is, the external scroll bar isn't resizable either.
Really?
Yeah. I don't know why. It's not resizable this way.
Yeah.
Maybe through the environment variable, maybe it is, but like I said, we couldn't use that.
Well, yeah, because if you try to change an array, you make an array of a button or anything.
Oh, just make one right now?
I mean,
I don't know, let's see what array control. Array of buttons, you said, just.
sure. I mean, I don't know if you have vision installed, but that's what I did. And I think it would work for a button.
And then drag it down. See, we
Yeah,
didn't
that's
really
fine.
use arrays, but
They say vertical scroll bar, and then try to edit that.
okay, it looks like it is letting me.
It is until you save it and reopen
Yeah, and then maybe that's the flag that would.
it. But anyway, try to.
Now I don't know exactly how to get this to be not under the button.
Actually, you hit Control J, select to make it go front.
Control. Oh, you make this go to the front.
Or just slide it.
Just slide it with an arrow.
Control J.
Just use the arrow to get sideways.
Well, yeah, I could move it, but if I slide it, then it's going to be outside of the frame. Well, now I can't select it. See, because now it's outside of the frame.
And now but you can't select the frame.
See,
Try changing the frame size.
yeah, you won't let you
Just
select
change
the
the
frame.
frame size.
Anyways, okay. Enough time spent on that. That's okay. Yeah, I don't know how you do it with the array. Luckily, I didn't have to use the array very much, but yeah, that would be hard to try to figure out how to do it with the array. And this next one might be the way to do it, which I said is with the Q control. And you can see here's the regular scroll bar. Here's the Q control one. You'll have to go read more about what Q controls are, but suffice it to say it's a replacement for X controls. And so it kind of has that same niche. But here I have it controlling the string, and I can turn off the actual scroll bar and just have it control my string. And so
that's what I did, but I did.
So what this ends up really being under the hood is it's a cluster with 2 buttons and a slider. But because it's a Q control, all of the functionality controlling it is in its own little asynchronous event handler. So that's why it helped me there. Okay, another thing, okay, now going back to the slides. Another thing is menus are too small, especially when you got to the edge of the screen. It was really hard to click on those. So as you saw in my demo, we changed those out to be tab controls and buttons. So looking at, yeah, let's just look at it. So looking at the menus, you can see I just control it with clicking on the tabs and it switches between them. And then the closing and opening is controlling a splitter. So I control the splitter to move up and down to hide. So splitters have a property that is position, and if it's a horizontal scroll bar, that position is the vertical. And if it's a vertical splitter, that position is the horizontal. So you can just control that property, and we animated it so that it doesn't just pop open, it kind of slides open and
So you do a phase.
stuff. Yeah, we have fades too. And here's submenus. If you have a submenu, it's actually a pop-up BI. And you click on the button and then it passes back to the parent. And then LabVIEW. Okay, and then it's smart enough to know if a submenu is open, not to close if you leave the menu. If it's not open and you leave the menu, it automatically closes. So it's got some logic in there. The menu was actually created before Q controls, but I'm thinking about recreating it as a Q control so that you could implement your own menu easier. So all of the logic to do the opening and closing would already be handled for you in its own event handler. And you could just bring it in, give it the reference to the tap control, give it the reference to the splitter, and everything else would be handled for you. All right, let me go back to the slides again. And we'll cover a few more slides. So dialogues were also a problem. All the buttons are too small in the standard dialogues. So we had to create our own library of dialogues that had larger buttons to them and make them so that they were smart enough to resize depending on the text you sent to it and all of that sort of thing. So not only did we have a standard set of controls as a library, we had a standard set of dialogues as a library. Also, the built-in keyboard was too small and didn't fulfill the space requirements. So we couldn't use the built-in on-screen keyboard that usually comes with Windows. Now this is a picture of the Windows 10 one. We were in Windows 7 and that one looks a little bit different, had even less room. It all came up really small by standard and all sorts of things. So we had to build our own on-screen keyboard. So we had all of the buttons in there. We had it if you held down the mouse or your finger a little longer on the screen, then it would do the select and paste and cut and copy buttons and everything. A couple of lessons learned from this is we implemented them essentially as dialogues. They just popped up. It made it hard to see things that were underneath it, obviously. So how did you enter stuff? Well, that's why we had to have an actual box on the keyboard to do the entry, and then you hit enter, and then it put the actual value into whatever control needed the text entry. We also had decided we had to come up with more than just one keyboard. We also had a numeric that was just a 10 key. So if you were just entering a number, it was a little bit easier. So let me show you those. So the demo, the dialog box, pretty simple. I mean, there's one of the regular ones. There's one of ours. We also made it so that you could have decals or not. And we also made it so that you could give other information, like question, or if it was an error, it would display that. Had up to three button ones. And all of the text and everything was stuff that you could pass to it, so you could, just like a regular dialog box, we just had to make it bigger.
You don't have a mat button?
So, what's that?
You don't have a mat button?
No, you could change to that. But anyway, so now going to the on-screen keyboard. This is why I needed to have, let's see. So here's the on-screen keyboard. Now for Windows 10, they made it so it's resizable and stuff. We probably could have went with the on-screen keyboard if that was the case. You can type stuff, but it has sound built in. Well, I decided it'd be fun to build in sound to this one too. So here's our built-in one. Now you can move it around and do all sorts of stuff. So in some cases, you could move it and you could still see where you were entering. And then you could type and hit enter. And so we were actually launching that one asynchronously so it could update the thing live. But in some cases, if you did it on the middle of your screen, it was not easy to see it. So anyway, we also made it so that it would respond to the regular keyboard just so when we were developing it was not a pain. But, there it entered into a multi-column list box. Here's an example of the numeric one. So if we enter something in there. Anyway, so that was the on-screen keyboard. Some of the problems that we had with it though was because it was implemented as a dialog box and edits the controls directly through references. it's not like it responded to Windows events or anything like that. It wasn't, like it was passing those keystrokes through the Windows layer or anything. It was passing them right to the control. So anyway, any questions about that so far? Otherwise, move to the UX considerations. So UX considerations, well, when you're dealing with a touch screen and you don't have a keyboard, well, keyboard navigation totally doesn't make sense anymore. So tab order doesn't matter, enters on buttons don't matter, alt keys for doing things don't matter. You don't need any of that. It just doesn't make any sense. Especially in our case where our on-screen keyboard didn't execute any of the Windows events or key presses. So, yeah, therefore touchscreen is not for the unsighted because there's no way to know where the buttons are.
The Air Force is discriminating against unsighted people for fixing its airplane.
Yeah, go figure. Okay. But something to consider. Okay, another thing is right clicks. Right clicks are hard to do on a touch screen. Well, they're not really that hard to do, it's just a longer press. But how do you differentiate between, did they press just a little too long and now it registered as a right click? So you don't want to have any right click menus. You want to take those all out. And in some cases, you might want to just put this little event in that made it so that any right click just turns itself into a left click so that they don't accidentally try to do a right click anyway. So, and what's kind of cool is if you do this, you don't have to do this for every single UI control. If you do this for the pane one fires first before the button one that's in the pane. So you could intercept the click before it gets to the button and then have whatever code for the buttons after that. It's the filter event that you have to use to do that. So, likewise, double clicks are just as difficult on a touchscreen because did it register both clicks, especially when it's a force one like a resistive touchscreen. Maybe a capacitive screen's a little bit easier to do double clicks, but you notice we don't have you do double clicks on any of our tablets or smartphones for good reason. It's just hard to register to make sure that you clicked it right or you just didn't bump it. So again, you can filter these out. The mods, the top boolean there is the double click. You just change that to false and then it acts like the double click didn't happen. Okay, minimize text entry. This is just a rule of thumb. For touchscreens, even though we did have an on-screen keyboard, we tried really hard to make it so that places where you normally enter text, you don't enter text anymore. One example of this in like a tablet, smartphone world would be, when you're filling out a form and it got to like state, you used to type in the abbreviation for the state. And nowadays, they don't have you do that. They have you have a selectable list and you scroll through and just select the state. And that's just minimizing the text entry. You can do that with combo boxes, numeric controls with the increment and decrement buttons. Maybe that makes sense depending on what use case you need that control for. Okay, now minimizing clicks is a little bit of a hard thing to describe because it's totally based on your use case. Can you reduce the number of clicks by rearranging the controls? Can you reduce the clicks by having one click mean multiple things, like selection and OK on a dialog box? But then there's the balance that, okay, maybe they accidentally made a selection and you want them to have another physical button that they go press to actually make that selection the selection they really wanted. Yeah, it's a trade-off there, and it just depends. And maybe it's on the criticality of the selection. If it's not that critical and they select and they can just go back in and reselect, maybe making it one click is okay. If it is critical, like a safety concern, and they click once and then they have to hit like the go button to make the machine actually do something, then maybe that's a consideration. So there's this balance between how much screen space you have to put extra buttons and things, and what functionality you need to have it do. So dismissing pop-ups. This is one of the places I experimented with. I'm going to go ahead and show you up to that, including that, and then we'll talk about it. So let me go back in. So filter clicks, this is easy enough. Okay, I'm going to actually use my touch screen here. That's actually representing a right click. So one thing, LabVIEW doesn't capture gestures, so, you know, this is the right click, this is the left click. If I toggle the filter, so now the filter's turned on, and I go do a right click, it calls it a left click. And it will execute the left click functionality under the click.
How do you get that big box? Is that part of the screen?
Which one? The checkboxes?
No. When you press.
Oh, this is part of Windows. Just doing Windows and press and holding, that's a right click in Windows. Okay, dismissing pop-ups. This is kind of interesting. So I was experimenting with how to do a pop-up that I could just click off of and it would dismiss itself. It would know that it was not active anymore. Actually, I should have done something on the slides real quick first. So there's two different events that you can use. There's a deactivation event and an activation event that actually says what VI is active right now. And all of the VIs get the same thing. So if you use, I think I used the VI deactive, it says basically my name isn't equal to the name of the VI that just went, just got deactivated, meaning it lost focus, is what it really is. And then it dismisses itself. Well, I found some interesting behavior when I was messing with this. And it has to do with when a VI is activated or not. So, obviously if you did invalid, it crashes things. So, don't do that. This is the same settings you can do in the VI properties. I'm just doing it programmatically for ease of the demo. But if you made it floating auto hide, which is the default if you make it floating, then it won't auto dismiss until you click on it and then click off it. The reason why is because there's no activation event, so it was technically not active yet. If you use modal and launch it, it'll deactivate itself, but it also gives you that lovely warning, just like if you tried to click off of a modal dialog box. And that wasn't desirable, but maybe it doesn't matter if you don't have a speaker, then whatever. But actually, if you just set it to floating, you do get the behavior you want, which is it auto-activates when it launches, and you can click off it, and it deactivates, and everything's happy.
Did you use the mouse lead?
No, it uses that VI deactivation event. So what that does is on the launch, the VI activation event fires whether or not you actually register for it, it doesn't matter. In the case of the floating and the modal, just like I showed, if the VI activation didn't actually happen, like in the case of the floating auto hide, then the VI deactivation doesn't actually fire. So registering for it didn't matter. Let me go back and do this one again. See, registering for it doesn't matter. It's not going to fire because it's not active yet. So it's not until I click on it, now it's active. Click off it, okay, now the VI deactivation event fired. That is these guys right here, VI deactivation and VI activation. They're actually events that you get when you enable scripting, but they are allowed in an executable.
So those aren't available if you don't.
They're not. They won't show up in your events unless you enable scripting. So, okay. Caveats, like I said, modal or floating, it automatically activates, so the deactivation will work. The floating auto hide, it didn't, and so, yeah, deactivation won't fire unless it's activated first. And then one caveat to this is limit it to 1, because if you don't limit it to 1, you get into this weird state sometimes where there's a deactivation event sitting in the queue, and you open the VI and it automatically dismisses itself. And because it dismissed itself, it's no longer active. So there's another one sitting in the queue. So you open it up again, it automatically dismisses itself again. And you get this weird state. So make sure to limit the deactivation event to only one and you won't get into that state.
You can only do that with one VI.
No, you can do it with every VI. You just have to make sure that you compare what VI got deactivated to what name the VI is. See right here where I have here's my name equal to the VI's name that got deactivated. As long as that happened, then I would shut the VI down. If it was another VI that got deactivated, it just means another VI lost focus, then it wouldn't do anything. It was a no-op. The way that I programmed it. Now, if I didn't do that comparison, if I just said, if deactivation happens, shut down, then you would probably get into some weird state again where, because the main, as soon as this pops up, this becomes active, the main VI deactivates, this event fires, passes the main VI's name to it, and now it would shut down if you didn't have that equals. So gestures, like I said, Windows gesture controls and multi-touch obviously aren't available to us in LabVIEW. They're not passed to LabVIEw. So how do you do all sorts of cool stuff like swipes and motion and all sorts of stuff? Well, I'm going to show you some. So it ends up being that you have to use combinations of mouse down, mouse up, mouse leave, all of those things. And mouse down and mouse enter. So let's see. So here's some that I programmed, and again, these are using my Q control toolkit. So here's a list box that just has a selection, and if I swipe, and I'll do it with the mouse so that you can watch it. So I swipe, I click, I swipe, and it slows down, it does all the animation and everything. And then, let's see, we've got to get to the right number, which is 42. There you go. And we can select that one. So this is by nature of using dynamic events. The mouse down, it registers for the mouse move event, and then it keeps track of where the mouse leave or the mouse up happens. It then calculates, did I travel? And it calculates the initial rate, and then it uses that initial rate and has a slow down routine through a timeout that then slows it down and does that. And so this is just doing it on a list box.
Is this available in Popups?
This is not shipped with the Q control toolkit, but I do have a link to where you can get it. But you have to have the Q control toolkit from the Tools Network, or if it's a VIPM, download it through VIPM, install it, and then install this, and then it will work. All right, here's another one I created. So this is the rolling drum that you see on smartphones and tablets, where it looks like it's a drum rolling and you make a selection, and so you can swipe on this one and it goes through. This one is actually based on just a picture control. So it's drawing the picture control and doing that. And what's kind of cool is something that kind of happens serendipitously is you can see how it does the little, like it's mechanical and it's moving into place. Well, that's my routine that as it's slowing down and it knows it needs to slow down to a specific spot, it tends to overshoot and then it corrects itself. And so every once in a great while it doesn't dampen out and it just sits there like this. But most of the time it does, and I'm not going to fix it. It's good enough. So. Okay, the last one I'm going to show is a swipe menu. So I have a menu bar here, and I can swipe, and I can make a selection. And so I actually have all of the icons on here twice. So there's dismiss pop-up 1 and dismiss pop-up 2, just so I can make it long, so I can show it. And then I wanted to show you, okay, well, what does this look like in the menu? So I have a menu tab here. That was hidden the whole time from you. And then there's what it looks like in the menu. And the buttons work. You just click on the button and hold down. Click on the button and hold down. Or you can click And when it gets to the end, it knows you're at the end, so it grays out the button. Get to the other end. Oops. Get to the other end, now it grays out that button, and so on. And then this one actually just has pop-ups that it's reacting to, one of the menu. So theoretically, all this is passing to the main program as a string saying which button was selected. So I could turn around and have these buttons that are in the swipe control menu do the exact same stuff that these buttons are doing. I just didn't have time to get that situated in the demo. So, but anyway, finishing off here. Let's actually push this back up to display. Okay, so capacitive touchscreens, they don't use a lot of force, but you can't use gloves. They're pretty accurate. Resistive touchscreens, you have to use force in order for it to react, so therefore you can use gloves, and accuracy depends. So just keep that in mind. So UI considerations, you're trying to make the different functions in your application accessible. So you're trying to place the right type of controls down to make whatever thing happen. Sometimes you have to rethink, well, maybe this would be better with a different style of control, meaning maybe instead of having radio buttons, maybe it just needs to be 3 buttons. Or maybe, you know, instead of a selectable, or maybe instead of a drop-down like a ring control or an enum, maybe because the list is really long, it makes sense to actually have it be a list box instead. But that takes up more screen real estate, the list box, than the enum. So there's the trade-off there. Then for UX considerations, you have to decide, okay, now we've got to think about the workflow. How are they going to click on this? How are they going to get to things? Is it a critical thing where we want to have a confirmation? Like most of the time for our shutdowns, we don't just have it, they hit exit and it shuts down. We have another pop-up dialog that says, did you really mean to shut down? And then they hit OK. You know, things like that. Just got to balance that real estate versus ease of use. So my presentation will be available eventually on either through the wiki, through the America CLA 2019. Let's see, I didn't actually put the links for the code. I'll make sure that those are available as well, and maybe I'll update this presentation to where those are, so that if you get the presentation, you can find out where those are. Most of my Q controls I've been publishing as G packages. You still have to go get the toolkit from BIPM, then you can download the extended Q controls that are based off of that from as G packages. There's also a Q control enthusiast page just on the forums, just like the Quick Drop or BI Analyzer, or any of those. And there's also a list in there of ones that have been created. And some of them not by me, luckily. Some people are actually doing this. So, okay, and here's some other important websites. Keep in mind. GCentral.org, we have actually a prototype of what we're going to talk about tomorrow. Chris and I are going to present tomorrow. Chris will be most of the talking. I think I'm just driving the slides. But then the wiki we talked about, and all of the other important sites. So that's it. Any other questions? Concerns? Oh, you want that one back up? Yeah.
So one problem I had with the Listbox is the Listbox was actually really long, and I wanted to color it.
Oh yeah.
And it actually created a huge lag for the user. And what I had to do was, I said, okay, how big is how many rows are showing?
I normally do those.
Have you ever run into anything like that?
So, do you use the defer panel updates already? Okay, because if you do the defer panel updates, usually you get good enough performance for UI time. Now UI time is a lot different than like data acquisition time, of course, because UI time is just based on how fast the user can react. And so normally, I haven't had anything so long that the lag was significant enough based off of using deferred panel updates.
Yes.
But that's a good way to do it, is to do kind of like a lazy load that only loads what's being displayed.
Right.
And I use something similar like with tree controls, where it only loads the layer that you can see, and then when you go click to open, it actually loads the next layer underneath that thing, so that it's a lot faster. You just have to do tricks like that.
I've actually had to, I've had Listboxes long enough, I buffered it to a file and then just pulled out the piece I needed based on a,
It sounds pretty hard to scroll through. Is there a different way you can do it?
You just scroll, and then you can use a nudge scroll instead of an actual scroll.
Maybe you can do some kind of a filter too, where you can type in some text to filter the list down. I don't know what your use case is, so.
Yeah, this was a long time ago.
Yeah.
So the product's been shipped in the archive.
Yeah. So I don't know, there's probably some other ideas there that kind of, when you get to this stuff, you kind of just start being creative, trying to see what you can do. There is a lot you can really do as far as manipulating UI with all of the different types of controls or properties and stuff that are under the hood. Sometimes you have to sneak in and open up the private stuff too, but then you have to be careful and know which ones you can play with, because private stuff are not always going to be there, and they don't always go with the runtime engine, so you can't always put it in an application. But I have done add-on tools where they're IDE add-on tools that just use scripting and run as source, where I have messed around with the private stuff too, so yeah. And go look up Q controls. The cool part about those, the brief summary about those is you can encapsulate all of your UI code out of your main logic. And what that buys you is then you can take and reuse that wherever you want. So one of the things that distributes with Q controls is like a tree control with checkboxes. How many of us have implemented that 100 times? You know, and now it does that for you, and it does 3 different ways that the checkbox can be implemented, either as kind of a radio button where it can only select one where you can just select down the list, and one where it does the whole hierarchical selection, where you select on parent and it does the hierarchical selection. That ships with it. That's an example. You can find an example finder after you install the Q control toolkit, so you can see how that works. Also, there is a getting started tutorial that's in the help after you install it that will help you create a really simple Q control based on a string control. It basically is for a form field. You type in your phone number, and if it recognizes the phone number format, then it turns green. If it doesn't, it turns red. So it's a really simple one, just to get your idea on how they work. Anyway, any other questions? Any questions about touchscreens? Okay. I'm not necessarily an expert about touchscreens. This is just my user experience from this project, but hopefully that helps you out. Thank you very much.